All right, so good afternoon, everyone. Well, we have a lesson to do today. Just kind of an idea where we're at, where we're going. We've got a lesson today, lesson tomorrow, lesson Friday. Then we're done with lessons for third quarter. So Monday, we're going to be going over ACT practice. Next Thursday, I'm working out. I have something in mind. We'll see. I may finalize that yet. But today, we are on page 25 in our workbooks. We're going to talk a little bit more about quadratic functions. Our lesson here, we're going to build quadratic functions from geometric patterns. Can someone tell me, what does that word geometric mean? What do you think we're talking about? What comes to mind if you think geometric? Geometry. What else? Something you can, what's that? Shapes. Exactly. We're going to think about how to find these quadratic functions working with shapes. So, get us started. I do have 3 learning targets for us. Can I get a volunteer to read out our first learning target?
Yeah. I can recognize quadratic functions written in different ways.
Thank you. Can I get a second volunteer? Who'd like to read out our second learning target? Yeah.
I can use information from a pattern of shapes and to write quadratic functions.
Very good. One last one. I can have one final volunteer to read our last learning target. Who'd like to go for it? Manny?
I know that in a pattern of shapes.
Exactly. So we remember with our functions we have an input and an output. We talked about our independent variable and our dependent variable. What this is telling us is that if we choose some step number, that's our input, we're going to find out how many squares we have as our output. Just like we did yesterday, looking over that problem, talking about with dots. We're going to be doing that today, working with squares. So to get us started, I have a warm-up for us on page 25. We have these 3 different figures. So figure A, it's just a large square. Figure B, we have this large square, but if you notice, there's a piece missing from this. And lastly, figure C, we have 2 large squares and 1 smaller square added to this. What we care about is what's shaded in blue. So what I want you to do is, I want you to write an expression to represent the area of each shaded figure. When the side length is what's given, or the side length of the large square is, what's given here in the first column. But something we need for this, just a quick refresh. What's our equation for the area of the square? Length times width, right.
Yeah, that's what I meant.
But what's special about the length and the width in a square?
They're the same.
They're the same. So we can say the length equals the width. So, I want you to use this equation. Think about how to find these areas, given these 4 different values. So, let you work with your table teams, and let's see what we come up with. All right, tenants here. Yeah. No. Oh. Here we go. That'll work. Actually, wait. Here, use this. Let's be smarter. There we go. All right. Give me 1 moment. Get the tenants taken care of, then we're good to go. Cool.
Today's Wednesday, right?
All right. So what are we thinking here so far? That looks right for that first one. If I change it though from 4, what are we going to have? Or if we change it to like x, what's it going to be? Well, how'd you get that 16? Right. Yeah. Yeah, trust yourself. You got this. So that's length times width. What is the length and the width for this one? For the second one?
Oh, for this one?
For the second, really quick. Not quite.
Wait, because it would be 16.
Yeah, because you're taking that away, right? Okay, keep following those ideas. Talk with each other and see where we get. How's it going, Kevin? Okay,
So C is
one small
two.
change we gotta make here, right?
Oh, that's not plus one.
Well,
Oh, yeah,
this one's gonna
16,
be a little
32,
different.
32.
Let's talk about B first. What's the area of the square we're taking away? Right. So what's
So
that?
X would just be X squared.
There you go. So find what the B's are. I recommend find the area of A.
16,
And you go from
32.
there. The first one's right.
It'd
Revisit
be
that
X
second.
squared, and then it would
You
be
go from there.
X.
So we're just on page 25 right now.
And then
We're taking a look at these different figures.
two.
We're gonna say that first
No,
column is the
it's gotta
side
be
length of the
two.
large square. And we're gonna find what these areas
You're
are.
eating.
Alright, let's get started.
Oh, so what the thing?
Yeah.
Four X, yeah, yeah.
Same thing I did in
EFT tomorrow so I can retake a test.
Sure.
You never wanna talk about
Worst case scenario, send me an email in class, remind me, and then I'll make sure I have that sent. I got you. Alright, how we doing, guys?
I'm doing alright.
Okay,
I think this is how it goes.
that first row is looking good to me.
Is the second row starting to look good?
These are good. There's gonna be a little bit more to do here with that next one. Okay. So you're on the right track with this, right? But how many of the big squares do we have in C? I think you got it. Yeah, there you go. So we're on page 25, give these a try. Okay, how we doing, guys? Okay. This one's right, this one's right. I'm gonna change these just a little bit. So let's look back at these. This one won't just be 16x.
Well, that sounds,
We're doing 4x
That's
times
a lot.
4x, right?
at the time.
So 4 times 4 is 16. What's x times x?
My friend gave me a script card, and they said, there's like
And
only
we
some
can't take away.
activities to
Just
look
like,
at.
do what you did
And
here
then
with
check,
these.
there's like $30 left on them.
Make sense?
You didn't tell them that, right?
No.
This would be 4x.
Oh, yeah. So $30.
4x.
I mean,
You just
there's
have-
only small things you can.
But what you have here,
Yeah, you could.
basically.
Like if you just go there.
Waffle sandwich.
Makes sense.
I like the waffle sandwich.
Just get like a sandwich and a drink and
So pretty good name.
Probably like.
Yeah, keep that.
just a sandwich and a
Good.
drink.
Yeah.
You could do
How we
that.
doing? Alright. Let's think about, what's the area of this small piece?
Always, but if you're using a gift card, always take the receipt with it. The receipt
What's
with
the
it.
area?
Yeah.
of the
it has,
You should know this by heart.
What's 4 times 4? Minus 1 times
Yeah, a lot of people, when I did with customer service, a lot of people didn't know that either, so I was just like, okay, you have this much left on your card.
Yep, 4. And that minus 1
I would always
times
just tell them, so that they're not like, oh, how much do I have?
1. What's 1 times 1?
Or like, how do I know? That's not right. That's on.
So area of B is 50.
I do that too.
Double check, see, you're close. Think of what the area of one big square is, find out how many of those you got, and go from there. So, give us a little bit more time. I'm gonna start to look, and have us fill these out.
Sounds real good right now.
Four X, 4x, x plus 3. Alright, got a little bit more time here, but I may come around and ask, see if I can have some of us do something on the board. So, still keep working with your table teams.
Nah, that's well.
Alright, see what we're finding here.
keep.
Okay,
Probably the shirt that actually.
you're on a good track. These here are right. There's one thing here. How many big squares do we have? 2. The area of one big square is x squared. How would you change that? Maybe not gonna change the exponent. But I need to count how many of the big squares I've got. I have 2 of them, right? If you do it as 2 times, you're gonna nod. Make sense, Mark? 2 times of your x squared? So just 2 times your x squared? Yeah. Plus 1. Because you've got a whole x squared, a whole x squared. Make sense?
Fiance for 6 years.
Okay. Can I have you tweak one little thing here? And then I ask you to column for him? With this, you did 4 times 4, right?
Did you hear about it?
What's gonna be x times x?
White doesn't drink anymore.
X squared
that means
It used to be
16
a
x squared.
column until it's big.
You got the idea, you got the heart.
Something.
So,
Is everything else right?
Appendix.
smaller tweaks, we'll talk
Yeah,
about in here.
burst.
But do you want to write what they are for A on the framework?
This is like
You want me
kidney.
to write A?
Yeah,
Even
just
this
the
one?
column,
Kidney
yep,
first.
That
Just-
one,
Like
this
you won't
one's
be
right?
able to
yep,
process
just
it.
straight down the column, those are all.
Oh, yeah, I can do that.
Perfect, thank you.
Right now?
Sure. All right, let's see how we're doing.
I don't even know if I got
Yeah.
this right.
No,
I don't know about that.
Okay. Mhm. Just one real small tweak. You got the hard one. So this is the x times the x, right?
yeah, I see.
But it's
It changes all the time.
4x times 4x. What's 4 times 4? So you gotta change that to 16. Yeah, so it'll be the 16x.
Tyler's,
So if you change that, you change that here too,
Tyler's a piece of garbage.
or 16x squared.
He lived with his dad.
Is the X squared?
Until last year. But he paid
There you go.
rent,
Does
so,
that make sense, Mark?
yeah.
Yes, you may.
yeah. What a guy. You're like my
There we
brother,
go.
all right.
How's one thing?
I don't know, I don't understand.
Okay,
It seems like
well, let's
he
think about
and
this a
Tyler
little
are
bit.
like best friends.
So,
Until they get
you got these
fight.
right, and we're taking these away.
Yeah, they got into a
How'd you
fight.
get this 16? Right, so this one should be
Until I
x
went
times
like
x,
this
right?
for like 10 years.
What should that be instead of 2x?
Oh yeah, I should. Said
X
something
times
along
X.
those lines about fighting.
It'll be different, you had x plus x there.
That's crazy. It's
So what's,
17.
there we go.
College.
Things are thinking. If you need a new pencil, hold on. Worst case scenario, have you sharpened this? Go from there. Let me see what you did. I think you simplified this out. What was this before you did some simplifying it? Where did this come from? Yeah. So this is like this, I think, right? How do you write it up in this? Did you do this column, but just write that one out? Awesome. There's a small little change there, we'll talk about it. These are, one side was this. All right, still checking with our last column here. Okay. This here is just gonna be x plus 3 squared. Just like how you have the others here. X squared equals 6. But it's just x plus 3 parentheses. Does that make sense? Yeah, the whole last row. If you make that change, would you mind writing these for column C? Because you got that. Awesome, thank you. So we're getting close here. Getting some ideas from around the room. Well, actually, we can talk through the last ones. I won't drag us up here for this, but this is looking good so far. Where do we think this 16 came from for our first one here? How do we find that to be the area?
4 times 4.
4 times 4, right. We're taking our side length times itself, because the length does equal the width here, and get 16. What about when we change to x? Where's that x squared coming from? What's another way we'd write that, basically?
X times that.
Exactly. We're still just doing length times width. Now, I'm glad we have this here. I saw something going around the room. Something that can be easy to get tripped up on is with our next one. We have 4x times 4x. We don't just multiply the x's. We are going to have an x squared here. But we have to also do the 4 times 4, which is 16x squared. This doesn't equal 4x squared. If you wanted to write it that way, would equal, in parentheses, squared. So, just an easy little catch going through that. And we can see with our last one, we just had our x plus 3, just our side length again, and just squared it. Why do we think we've done what we've done for column B though? Why do we have the patterns that we do? Where's this number coming from? Yeah,
The little block missing from it.
exactly. We're taking away that little block, and what's the area of that little block?
1/4.
1. So you're pretty much just taking what you had before, you have that same square, and just knocking that little piece out. Let's talk through the last one here though. What should our area be for C?
33.
33. Where did that come from? Because that's exactly right. But how did we get there?
I did 14 square, which is 16.
Okay.
Multiply that by 2, then add 1.
Yeah. So we're going to find what our side length is. Here it's 4. Square that. That's the area of one of these squares, right?
Yeah.
We've got 2 of our big squares, and we add that 1. How would we write that then for x? What's the change we make here? Instead of 2 times 4 squared plus 1. What do we think the pattern is with this one? Great, I know you guys got it around, right? What's it going to be here with side length of x?
X squared times 2 plus 1.
Yeah, this is 2x squared plus 1. Just 2 more, and then we'll keep moving. How about our third row? When we change it to 4x, what do we think? Think about how these are related to each other. What's going to be the next step in this pattern? Yeah.
Would be 32x plus 1,
Need one little thing.
x squared.
You got it. 32x squared plus 1. We're just taking double our original square and adding 1. So if we do that same thing, double our original square and add 1, how am I going to write this for my very last one? What do we think? Well, what did we have? How would you say this one? What do we have for our square A for our last one? You think about, we've got this side length of x plus 3, right? The area of one of these squares is just going to be that x plus 3 squared. I have 2 of these plus that additional 1. So I know that last one can be a little weird to think about. We're mixing a variable in here. I think some of us wanted to multiply it out. Just think of it as a length for right now, and we're treating it just like any of these other squares. All right, well, I want to keep us moving. Think about these patterns, because I want us to think about this pattern of expanding squares. So we have a pattern happening here in steps 1, 2, and 3. I want you to think about if this pattern continues, what are you going to see in step 5, and what are you going to see in step 18? Now, I know that's a big jump in numbers. Here's something that can help you think about this. What stays the same in every step, and what's changing? Once you've figured this out, you can just describe it. You don't have to draw it. Actually, I'd rather you not draw it for step 18. When you understand, you'll see why. I'd like you to tell me how many small squares you have in each of these steps. As you do that, you should start to see a pattern. And think about how to write an equation. Just like from our learning targets, we're going to talk about, we have our step number n and the number of squares y. That number of squares y depends on n. So we'll have some function y of n equals something that we'll find. After you've done this, I just want you to think about sketching the first 3 steps of a pattern for n squared minus 1. So let's talk with your table teams. Let's see what we can come up with. You ready to go? Okay. So now we're going to
Understands to make me.
is we had these different areas. So this square is just going to be our length times the width here. And this is the same thing here, but we've knocked this little 1-by-1 piece. This one, we have 2 times whatever this was. So we have 2 big ones. This one. So we're just doing that same pattern all of these. Make sense? Kind of? I know you're kind of jumping in midway. That's okay. All right. So think about what stays the same and what's changing. That can be a hint to help us figure out what's happening.
It's quadratic.
Would it kind of be, like, x squared, and x would be this inside thing plus 4?
I think it very well might.
Every other step, it adds 1 on to x.
And it makes good sense to me, yeah. That's like our step number, right? And those numbers make sense to me. You can see why I don't want you to draw 18.
Yeah, because it's 18 squared plus 5, which is,
So, maybe not plus 5, but you're real close.
oh yeah, plus 4.
You got it, yeah. I knew you had the right idea. Yeah, find those numbers. I know Gavin has them here. Think about that and then write your equation. Yeah, you can share, talk to the table team. That's the idea, work with each other here and see what you come up with. All right, how are we doing? I don't know. Okay, those numbers are making sense to me. Good, those numbers are making sense. Like this.
Well, my handwriting is terrible, so.
It's not
What
165.
do my numbers say if I look at you already?
That's 20 on the negative.
Oh, well, because you knew the answer.
Yeah. So, let's think about, what's staying the same every time? So, let's just look step to step. What stays the same in each? Right, it's gonna be like, we're gonna add 4 something, right? Alright, how many do we have on the inside? So 2?
That'd be good. I'll have to
What do you think
focus.
we're doing to get that one?
I'll have to take. I should take one of those before the crazy team.
That tastes like math.
Yeah, how many across do we have?
The min.
You gave me him.
So what's in these areas? What do you think it's gonna look like
I
inside?
remember I slept just fine.
Yeah, they're supposed
I'll
to
feel comfortable.
use,
We'll still have those out.
Why not like 8?
That's what it's supposed to be. Now check on your calculator, find that.
What's that camera?
What's the equation gonna be for us?
You did that wrong. If it's a sign, it's a
Alright. Once Christian's back, yes. Okay, that's not right.
you remember to math?
Good. Excellent. You can see why I said the draw one. Step back.
Technically, he overdosed on something.
Sorry guys, my cough's still here a little bit. Okay, let's think about
His
this.
body's still probably overdosed.
You're not in the frame I am.
Yeah, sorry guys.
I'll feel comfortable with this.
It's okay, just for today, sorry. But let's think about this. Think about what's happening with this pattern. What's staying the same every step? Yeah, 4 on the outside. So whatever we're doing with the inside, we're gonna add 4 to it, right? Yes, let's do that real quick. Let's see. Yeah, no, there's one to swap real quick. Or do you want to swap to another team? I'll just swap to another team. Yeah, if you want that. Okay, let you decide.
She's really ready to get to the bathroom when the wiper comes back.
I think there's a bit of a line once Maddie.
No, she's gonna take like 20
Oh, I
minutes.
know,
I
I
just
just
wanna
wanna
It's Christian, then Maddie's and you.
Maddie, you take like 10 minutes. I just
Don't.
wanna go to the bathroom. She's gonna be out.
5 minutes.
Okay. We'll worry about it when we get there.
No, come
But
on, can
let's
you
talk
take
about this
that?
first. So we're right about that +4, right? You get that 4 on the
Yeah,
outside?
it's like
Let's think about what's happening on the inside. How many squares do I have on the inside in step 1? Well, wait, how many in total do we have here? And then how many in total here?
No.
9, right? 1, 4, 9. You're exactly right. Yeah. So what she's saying is it's taking this step number, what times itself, and adding 4. So how many do you think we're gonna have in step 5? Okay? Right. Because it's step 5. What's 5 times 5? And then add the 4.
Oh, no, I don't think so, man.
That's
He works
29.
like on Wednesday.
So that's how many we're gonna have there. You'll want a calculator. Think about that for step 18. Please don't go on step 18. Just talk about it. Yeah. It's a big number. Talk about that. See what you come up with.
200.
Maybe a little higher.
Oh,
Not 228.
328.
There we
I
go.
think I wrote the.
Yeah, we'll talk about that.
328.
So I'm hearing the numbers, but what are we thinking of this process, guys? You've got a drawing, right? All right?
Quadratic.
Exactly. can see that change that's happening, right?
What does that mean by
What's
this?
five?
Is that the one?
That's the numbers here, yeah. So giving those numbers is what that's asking. So how many squares do we have here with our set 5?
No, my run, you're gonna touch me.
Why don't you count them and see? 29, right? Okay.
Oh,
So don't do it for 18. Don't try and draw out my hand for 18.
You can just
So let's
do
think.
5 squared, just 25, because if you look at step 2, it's 2 times 2 is 4 on the inside, and then 4 on the outside. You do 5 squared plus 4 equals 25.
I'm sorry.
Yeah. I gotta bring this for you, actually. I have a stash
You
now.
want me to group it?
You're welcome. All right.
I don't know how to like describe
It
this.
works when you do it like on your fingers.
So what you're doing is making sense, right?
I'm gonna do that.
So
He's got
that
it.
right there, you already got the hardest part. So talk about, like if it's step 5,
His hands are sweaty.
what number are you on?
My hands are silky.
Talk about that for 5. So say that for 5 and say that for
You're
18.
small hands.
You got
Hands
it.
are a little small.
You don't have to draw it, just talk about it. But you got it. Okay.
Go down to this.
I think we're getting to a good spot, getting close, ready to move on, talk through this.
You have eczema though? Yeah.
Maddie is actually,
Yeah.
not that long.
Minute,
If Christian's not back by 52, I'll let you know. What's
Yes,
it?
I have my hand with
I did.
Let's think about this. So you got this pad.
Just right now.
Okay. So what's our, oh, you had the equation.
Yeah, I just wrote it all up there.
I did agua.
Yeah, I think we're at a point where we can start to talk about this.
Wait, what is this one do? Truly like a lot?
We'll start to go through this. Yeah, okay.
That was it.
That's just what the numbers are for these. So we'll talk about the table.
guys are like,
Never do that again.
So like the 5 squared plus 4 is the
Yeah, I can
21,
do
right?
that.
all I can see is
That's what it is for 5. And then you have to do the same thing for 18.
Yeah, no, I.
All right.
What's 18? Bro, you have epics. Everybody has epics.
No.
So I promise we'll go over it just here in just a moment.
Yes, my line actually.
That's it. You got it. Good. Okay, I think we're at a spot where we can talk through this one a little bit. So let's kind of go step by step here. What I want us to think about is, you can go. All right, what stayed the same step to step? What was consistent every step? August?
The 4 squares on the corners.
4 corner squares. Right, that was there every single time. What was changing every time though? What changed every time?
The number of squares in the middle.
Yeah, number of middle squares. All right, well, let's think about then. What do we find? How many of these squares did we have on step 5? See if we can find the number, and then we'll start to talk about this pattern, okay?
29.
29. How did you get that?
5 squared plus 4.
You did 5 squared plus 4. All right, what about step 18? Where do we have just a huge jump out to step 18? How many are we going to have, Emma? Yeah. We're taking that 18 squared now, adding 4. It's 328. So that's why I didn't want you to draw it by hand. That was going to be a lot. Let's go a little further. Let's build our equation, because what that's telling us is how many of these we have at some step n that we choose. So this is our function, y of n. How can I write this, just based on what we've been doing? What's this function going to be?
N squared plus 4.
N squared plus 4. Exactly right. I even heard around the room, we can check how the number's changing step to step. How many squares did we have in step 1? What's that? It's just like, I think just Miss Sherella and our curriculum coordinator. That's it. All right. Let's talk about this. How many squares do we have in step 1 in total? 5. We have 5, right? How many in step 2?
7. Wait, no. 4, 5, 6, 7.
We've got 8. How many in step 3?
9, 10, 11, 12, 13.
13. So if you think about how this changed, here we added 3, here we added 5. I heard talk around the room, as we've said with this pattern, when you can see this changing by the next odd number, that's a hint. Something quadratic is probably happening here. All right. Well, now I want us to think about this last piece here, where I want the first 3 steps of a pattern represented by the equation y equals n squared minus 1. So we can talk about this one just a little bit. Y of n equals n squared minus 1. A little bit of direction to help with this. I want you to think about the number of squares you're going to have for these values of n. So let's take about another maybe 3 minutes or so. Let's work with our table teams and see where we get.
1 times 1 minus 1, that means 0.
Correct. So you can just draw 0. That one.
Your keyboard close to me.
Whoa.
Okay.
Yeah.
You can see all the stuff on the side. and I don't
All the
like it.
cherry switches. It's supposed to be lit up. Cherries, not lighting up right now.
I still
What
don't
is
like
it?
that. Like, that's like
What
all
size is
exposed.
it?
It's a 10 kilos. Oh no, it's
What is all
it's like a really small one. Actually, it's
You
even
can see
smaller.
all like the stuff on
Thank you.
the I don't like how it's
Can you bring me
exposed like
water bottle?
that. It should be like closed. And,
Someday.
if it's clear, that's
No.
not like an easy.
I love that
Just
keyboard for that.
Sunday on pieces.
It looks
I hate it. It bugs me.
It just looks cool. Mouse.
Just Sunday, yeah.
Sorry guys. Alright,
Oh, keys?
so
I'll like put the keys on there.
okay. Maybe not quite what they do.
Don got fired from
You're
Joe.
right, we're taking one away, right?
Usually,
Yeah.
usually
But
it's
if
not.
I do n squared minus 1, if I put in 1 for n, what's 1
Who's the
squared?
roller before me? Not even
1 times 1?
Oh, chair's still
And 1 minus 1?
so embarrassing.
So in step 1 we're gonna have 0.
There's children that work there for
Try plugging in those
years.
next numbers and see where we come up, or what we come up with.
Standing up.
How we doing?
Okay. Do we do this over here?
Still, maybe.
Minute.
Because it was like right there.
Plug in those values for n, and you need to think about what this is gonna look like.
Tickles did.
1 equals 0,
What?
2 equals 3 equals 2 times 2.
3? Yep. Good. Keep it up. Okay. How we go, guys?
I'm not too sure what you're at.
That is like nothing like this.
Yep. So with this first one, we're just putting in 1 for n in that equation, 1 squared minus 1. So what's 1 squared gonna be? And what's 1 minus 1? So in step 1, we have 0 points. Does that make sense?
That's all I'm shoving it. I was trying to,
I wish you handed it to me because I could have self outside.
it like did like the thing where it like sharpens like, I
Yep.
don't know. So I
He's
bent it
Because I just
to
don't like the keys.
I just kept going
over
wrong.
and then I actually snapped it and then I kept doing it and now I have this like.
Okay, we'll make it work.
But this actually would use a long time.
Yeah, that'll last a while.
When I used to say,
And a bigger, like, a full-size pencil.
Alright,
I missed being.
I think we're at a spot where we start
Okay,
to look.
so she's been going for 5
Oh
minutes.
man, if I was
We'll
training.
go one more time, and then I'll let you go. It's a decent walk down. So, let's talk about, let's talk about this. Let's worry about just this for right now. I promise, I'll let you go to the bathroom soon. Let's talk about this first. Do you have a thought, John?
Used to always
Okay. So, let's think about with n equals 1. I need to think about what I'm going to draw here. Am I back to? If I've got n equals 1, and I'm working with this here, how many blocks am I going to have? If this is my equation, I'm going to have 0, right? It's going to be 1 squared minus 1 minus 1 equals 0. Well, step 1, congrats, it's already drawn. We're done. So, we need to think about step 2 and 3 are not quite as easy. What about step 2? How many are we going to have there? 90. Yeah, we're going to have 3, right? Can you tell me a bit about how this happens? What do we do?
You just do, step 2, 4, and then minus 1.
Yeah, 2 squared minus 1, 4 minus 1 equals 3. We've got one last piece here, but that equals 3. What's that we're going to turn into? Yeah,
8.
8. Right, the same deal. 3 squared minus 1, 9 minus 1 equals 8.
We have a cool down.
We do. We'll get there, don't worry. So, we have a few different ways we can draw this. One that I like, you can think about making this full square, that's our n squared, but we just gotta take one away. I'm just gonna pick a corner piece to take out. So here, I'm gonna have 3 squares, and I've taken away the upper right corner. If I continue this, 1, 2, 3, 3 across this way. And again, I'm just taking out the upper right corner. You can draw this a bunch of different ways. It's up to you on how you want to show this. I would recommend try and show it related to a square, because you can see the repeat of this pattern. This will expand out further this way, but you're still always missing that corner piece. Just so happens at step 1, the only piece you can miss is the only piece that would be there for n squared. All right, got a little bit more to look at with our lesson, and then we'll get to our cool down. When we get there, sure. So we've got one more pattern here. We have steps 1, 2, and 3 of this pattern given. What I'd like for you to do is to sketch the next step in this pattern. Now, we have some students who are thinking a few different things about this pattern. What Kieran says is that the pattern's growing linearly, because every time the step number goes up by 1, the number of rows and number of columns are increasing by 1. So, just the thing with that, if we're thinking about a row, that's a horizontal cross, that's going to be a row. Column, it's like a vertical slice. So, we're just saying the rows and columns are increasing by 1. I want you to think if this agrees, or if this goes up linearly, if you agree with Kieran. Next step here is Diego and Jada, 2 different equations. Diego's is f of n equals n times n plus 2. And Jada's is f of n equals n squared plus 2n. I want you to think about these equations, and if you agree with them, do you think either's correct, both are correct, neither are correct? What do you think is happening here? All right, so take a look at this, see if you can find the next step in the pattern. We'll talk about this here soon. Ready to go? Yes.
It's not,
Can you please back? Yes.
it's not exponential because 3 to 8. You can't.
That's making sense to me too.
It's not exponential because you can't.
Okay,
you
either
can't
way.
multiply
That's
it.
half my.
It's a minute to the back, a minute in bed.
Okay, let's worry about our lessons right now.
No.
Okay.
I was so laughing.
Oh, I forgot to fill my water bottle.
So I want you to think about these other bits here. What do you think? Do you think this is changing linearly?
You'll take and buy me some of the
Okay.
That's the number of squares, what's
So yeah, how come?
Let me just use you for money.
Exactly. So you can talk about that. Say that that's not.
initial number?
I want you to think about these
Numbers.
numbers
I spent all
and
my money.
relate
Why
them to
not
what
just
this
do
is here.
n
So
squared?
we'll talk about it here soon.
I like
Give that a shot.
Yeah, hers.
Hers is simplified.
Yeah.
I have
Doesn't
$60.
make sense.
It makes sense, it's just not simple.
I had 300.
Exactly.
It's weird.
I could start with something.
Jada's
Does anybody have blueberries?
Jada's is the
Think about this
simplified
pattern. I'll
version.
check
Does
this.
anybody have blueberries today?
Yeah.
What'd you guys do?
Good.
Did you guys just
Can
have
I,
blueberries?
can I have you hold
Yeah,
that for a little
short
bit?
time on the essay.
Okay. So we're gonna find our next step in this pattern.
No,
It's good. It's not changing by the same amount. Now think about these equations
Everything
and see where we end up.
what do you do on class?
Okay.
No, I just also
How many
worked
guys?
on classes.
This is 9 plus.
What do you do in
6.
those classes?
It works! Sweet, Jada's works, which means Diagon's works, because Jada's is the
I actually, it's weird because I don't like doing
simplified version
that
of
many
Diagon's.
subjects
All right.
in
Let's think about
class.
this pattern, right?
classes.
Yeah.
You know what I mean?
How many rows do we have here? How many horizontal slices? How many horizontal slices? How many vertical? How many horizontal on the next step? Horizontal, that's right.
Yo, if you buy me some of those, I'll pay you
How
back.
many vertical?
Okay, just give me a.
Okay, so 3, 1, 4, 2. What are you gonna do? How many rows? How many horizontal? 5, 3, right?
Oh,
What do you think the next one's going to be?
Man,
They're like $20 under. No.
do you like leave the house at fun and other school?
5 rows.
Like that in East Lawn.
Yeah. 6, 4.
Cause I leave to go to school
it's so beautiful.
What you think is going up later?
No,
Do you
it's
have
better.
a gym?
So how many do we
It's
have
up,
here?
so.
How many here?
Oh wait, it's not.
I'm sorry.
You see it, yeah, yeah. That light bulb moment.
Or when I'm at work.
How's it going, Christian?
Do you work today?
So let's think about this one.
Yeah?
Alright,
Yeah.
so if you think about this, like our rows can be our horizontal slice through. How many rows do we have in step one?
You would like a gym?
How many rows?
I have a couple people hired up.
Alright, what about step two? How many rows?
Like all
Do you know what the difference between urban air and sky
Alright, we had 3 and 1,
Sky's always
4
better.
and 2. What do we have in step
Urban
three?
air is better.
They want you like.
How many
I don't know,
rows?
that's tough.
I'll be honest, I have my
I
urban
never
air.
said a name.
It's gonna be like 5 rows, 5.
Well, what's
Huh.
sky zone? Because I've
I
never
think
been
that's
to
what
Same thing, I
Check
bet.
one for-
It's
Trampolines,
probably
you got trampolines and basketball hoops, you got dodgeball.
Exactly.
Oh, it's the same thing.
I was at Sky Zone,
Urban
so like.
Oh wait.
That's
Urban
awesome.
air down to blue
Yeah,
right
yeah.
What?
Ah,
I just started going down to blue.
I want a Sky
But
Zone with
urban air has
with
the laser
Cobitos.
okay, urban air is better. You got laser tag.
Teddy bear.
You want green?
And Daniel.
They don't have
Alright.
Yeah, it also has bumper cars.
So,
Glad to hear some fun conversation. Let's pull it back to this for just a little bit longer though. I need to think about step 4. Can someone describe what step 4 should look like? What's our pattern that's happening here? Go for it, Evan.
Like the bottom goes from the same as what? Wait, what is? Hold on. What is the rows that's like this?
The rows, the horizontal cut, yeah.
Okay, so the rows are the same as the steps, and then the columns are the same. Like go up by one from the last. If that makes sense.
So this is like 4 across, right? And then how many high does this go?
6.
You got it. So here, 2, 3, 4, 5, 6. Yep. So what we're doing here is this on the bottom. That's exactly right. That's our step number. How many more than the step number does it go up by? It's like our step number plus how many? Plus 2. We're going to come back to that here in a second. But what do we think? Is this changing linearly? No. How many do we have in step 1?
3.
3. How about step 2?
8.
Next one?
Oh, 50.
15. I'll tell you this last one is 24. So this is plus 5, this is plus 7, this is plus 9. There's no consistent number we're changing by. So it can't be linear. It's every other number, right? Which, that's a lot like our quadratics.
Yeah.
Well, what do we think of Diego and Jada's equations here? Someone get to test these? What do we think? Yeah.
Jada's is a simplified version of Diego's, so they're like the same.
Can you tell me what you mean by that? How would I change Diego's to make it Jada's?
You just put the, I forgot what the word is, but you put the n, like in the parentheses, so it'd be n squared plus 2x.
Right. If I'm going to multiply this end to both of these, does anyone remember what this is called? It's some property.
Distributive property.
That's it. If we use the distributive property, these are the same thing. But what I want you to think about is what Emma said here. We've got that it's just our step number across, and it's our step number plus 2 going up. Our step number is n, right? So this is almost like finding an area. I go n across, n plus 2 up. N times n plus 2 gives us our area. So, they're both correct. All right, we do have cool down here. So, let me find where is the cool down? Right here. So I'll let you pass these out, Katie. All right, so just turn in your cool down before you leave. Have that in the basket here. Our homework tonight, actually going to be a short one. It's just 1 to 3 this time.
that might be the first homework I've done since the second one.
All right. So, work on the cool down. Once you're done with that, make sure to spend a little bit of time, work on the homework. And that's it.
Oh, this quadratic is very dated.
So like,
Alright.
n squared plus